Hi there, this is an update on desalination technology. We just saw a news item about a new type of electrostatic desalination, and I think it's good to simply go through types of desalination that you don't very often hear about. The most frequently used form of desalination is reversed osmosis, and that's the image that you see here. These are simply filters that allow water through but do not allow the salt, the sodium and chloride ions through. They are too big to pass it, and what happens is that that water is pumped under high pressure through these membranes, and well, on the one side it's saline, on the other side it's fresh. This is a widely used technology that is very energy intensive. It requires lots of energy to push that water through these membranes. Of course, if you do that, these membranes will get hot, and just like when you let's say hold your hand to your bicycle tire, it will start to burn just from the friction. So that's where the energy goes. It's dissipated from these membranes. But also the equipment is very expensive because it requires high pressure tubes, steel, and well, that's basically the reason why it's so popular, because it's economical. Economical means that you use a lot of fossil fuel energy to use it, and even if you use wind energy, as is happening in Australia in some places, where you have wind electricity used to drive the pumps to do the desalination, you still have lots of metal and steel and maintenance and all kinds of other economical activities that are good for consumption and are good for the turnover and the cash flows of the bank. So that's why this is the most popular technology. It's not because it's the cheapest, it's because it's the most economical. The second technology I would like to, well, this is just, let's say, the benchmark, reverse osmosis. One technology that I think is very interesting is freeze desalination. This is simply freezing water that is saline, which means that as it freezes, the salt is pushed out, because water that is saline doesn't freeze, and the more saline it is, the less easy it freezes. It will of course become solid at some point. So what happened in these freeze desalination plants is that the pressure is lowered. So there's a vacuum used to cool the water. That's called vacuum cooling. That's a not very well known way to cool, but it's also, let's say, one of these technologies that is widely used in industry and seldomly used for consumers, because it's too efficient. But you basically cool the water that it becomes ice, and then of course the ice will float on the saline water, so you separate the ice. And you have a washing facility that basically let's say tumbles the ice, so that you get a fresh water top layer and a salt water lower part of the tank, and you can do that a couple of times, and you end up with pretty fresh water, just like ice cubes, or like the ice from the North Pole. If you could basically sell that as drinkable water. It is partly, it is of course snow that has fallen from the sky, but for a large part it's simply ice that came from the sea. It's frozen, and the salt left the ice. This technology is more efficient, freeze desalination, than solar still desalination, so evaporating the water, because it takes a lot of energy to get from water to steam. That's basically a very big phase change, and that means that if you, let's say, if you boil water, for making tea, for instance, you would only need 80 degrees water, or coffee. That's actually optimal, but most people boil the water, which is a huge waste of energy, because so if you want to bring it to a full boil, you have completely transferred a lot of energy into the water, which is completely useless and not necessary for making your coffee. But in solar still, that same thing goes on. Of course, you can optimize it by creating a cooling part of the solar still that transfers the heat back to the yet to be evaporated water. But it's less efficient than freeze desalination, according to a study. Another nice part of freeze desalination is that you can use it with mechanical wind power or mechanical hydropower, because the cooling is done using vacuum cooling, and you can simply use a pump that you drive with hydropower or with some other type of mechanical energy directly, so not involving electricity or the conversion to electricity, to drive the vacuum pump and to cool the water. How that cooling works is also well, it's not easy to explain, maybe if you don't really have let's say the imagination to to picture what I'm talking about, but vacuum cooling is a very old technology. It used to be used in steam trains to provide air conditioning in the wagons, and there it was the vacuum was created with steam by basically just like you have airbrush technology. You blow steam over a hole, and that sucks out the air from the hole. That creates a vacuum that increases the let's say lowers the boiling point of water, and as it boils it will lose heat, and as it loses heat it cools, and so you get cooling. But anyway, there's another technology that I can talk about, and that is ionic desalination, I would call it. It's quite an interesting way to desalinate. It is based on renewables. The way it works is that you basically say, well, water is saline water, is water with ions, sodium and chloride ions. These are electrical particles. They are charged because they've separated in the water. They're surrounded by water molecules that have polarity, and because they are surrounded by water molecules, they can move around, and they will. If you put so if you take a battery and you put both the poles into water, you will see bubbles of hydrogen forming on one and oxygen forming on the other. But you also see, if you put some salt in the water, you see sodium accumulating on one, and chloride gas forming on the other. So using electricity you can move these ions around. On the other hand, if you turn that around, you could use membranes that only allow sodium through or chloride through, and if you put enough pressure on it, which can be osmotic pressure, so that basically there's a lot of sodium on one side and a little on the other. But basically what happens in these desalination plants is that you first create a gradient of electricity by pushing out sodium and chloride from a basin with a lot of sodium and chloride to lower sodium and chloride. I think that's the correct way to say it. I don't have the picture in front of me. So what you get is you have three basins, one with enormous amounts of salinity, and two side basins, one with a lot of chloride, one with a lot of sodium. The chloride part is negatively charged, the sodium part is positively charged. You then put those two basins next to a basin that has a little bit of salinity, so seawater, normal seawater, and of course the compartment with the sodium will attract the chloride out of the seawater, and the compartment with the chloride will attract the sodium out of the seawater, and so you get fresh water. The nice way about this is that it can be completely renewable energy driven, because what you need to start with is extremely saline water, so water with lots of salt, and you can get that water by simply drying out, taking a little bit of seawater and putting the sun on it, and then you get a high concentrate of salt water, and you can use that to desalinate. I've been talking about this, and I've been saying, well, this technology is very interesting for Israel, because they have the Dead Sea with lots of salt in it. They could use the seawater that they can ship over, or let's say put through a pipe over about 30 kilometers towards the Dead Sea. It's 400 meters lower, so you get hydroelectricity and you get desalination because of this process. It was discovered or developed in Australia. The whole idea of having membranes that only let one type of salt through or the other is quite old, but of course this application threatens the reverse osmosis desalination technology and industry, so you'll get all kinds of nonsense about it. What happened is they invented it in Australia, they moved it to Canada, they patented it, and I don't think it's going really hard with this technology. It's really not taking over reverse osmosis, while it does save about 80% of the energy needed to desalinate. So if you have a diesel desalination plant, you can imagine that you don't need diesel anymore. The water will be a lot cheaper, and it will still be very clean. So that's this ionic desalination. And then there's a new one which is using electric fields, and I don't really know how viable it is, but I'll just talk about it because it's a new technology and it's interesting. What the people do with this technology is take the saline water, make it flow through very small channels, and as it flows through that channel, an electric field is applied. The ions will move because of the electric field. Maybe they'll move a little bit, just simply separate themselves from the water. It should be comparable to creating a mist of water and then putting that into an electric field, which is used to get out dust and fine particles from the air. So you basically treat salt as a fine particle that is floating around in water, and once you, let's say, thin the water enough so you can apply an electric field, because electric fields, well, simply are potentials between two places. So if you want to get an electric field, you take your battery. There's an electric field between the positive and the negative pole of your battery. It's very weak. So usually if you want to have a noticeable electric field, you get static electricity, which is very demonstrable. So you just take a balloon, you rub it on against a wool sweater, and you can stick it to the ceiling, because there's an electric field that the electrons that you remove from the balloon create a negative pole, and then there's always positive, let's say there's always a neutral wall or something, and that will already attract each other. That's electric fields, but they only work if you have a non-conductive medium, like oil or vacuum or air is relatively low conductance. It's a good insulator, and of course in water that wouldn't work, because water is a very good conductor. If you put a little bit of salt in it, and that's the problem, there's salt in the water. So it would be very lossy and unenergy efficient if you didn't solve that problem. Apparently they did. So and they say it's much more efficient. It has no moving parts. It has, of course, water is moving. Of course, there's no membrane, so you won't be pushing it through the membrane. It looks like a one, let's say a one-go thing. So you just go through the system. They say it also cleans out bacteria and all kinds of other rubbish. Reminds me of the fact that if you put some magnets around flowing water, you also get electricity or an electric field between them. So maybe there's a better way to understand the whole method. I'll look into it. But this is already 30 minutes, so thanks for listening, and I hope you enjoy it.